Alright guys, Simon here, and I'm learning to make video games. So it's been a while since I've made one of these videos, and we are gonna do something a bit different today. In the previous 5 videos, I've been making things in Unity 3D. So this time, I was on holiday in Melbourne for a week, and I got bored at night because the internet at the hotel was really expensive. So I got Flash, and I started playing around with it, and I made this, Pentominoes. So I made this thing. Let me just show you what it does. So this is like a puzzle. It's a fairly old, mathematical puzzle. You have pieces like this, right? You can kind of flip them around, rotate them around. The idea with this basic puzzle is you see this kind of rectangle in the middle here. The idea is you fit all these pieces into the rectangle, and I've got one of these things memorized. Somebody gave us one of these puzzles, a physical copy, not a game. Not a computer game, a physical copy of one of these puzzles a long time ago, and I've been playing around with it since, both the physical thing and trying to make various programs to emulate the game. So this is a solution to this puzzle that I've memorized a long time ago, and I still remember it very clearly. So the idea is you can do that, and there's like thousands of different ways you can put these things together. So that's the basic program, and if you go to this site, I'll put the link in the video description. If you go to sites.google.com, let me just make that bigger for you if I can figure out how to use Notepad. Let me just do that, and then format font. Let's make this like a 20 size font. There we go. So that's not it. That is a video of Steve Jobs. That's not the right thing. So if you go to that side, there we go. So that's I'll put the link in the video description, as I said. So yeah, so then you can go have a play with this. And right now that's all it is. You move pieces around, you can rotate them, you can flip them. It's lagging a bit because I'm recording. And if the pieces overlap, they kind of bounce back to their original starting positions, because I don't want the pieces to get buried underneath other pieces. But aside from that, that's pretty much all the functionality I've got so far. So it took me a week, maybe like an hour, half an hour each day to get this far. So yeah, so go ahead and play it, and I'd be interested to hear your opinions on how it can be improved. How can it be improved? I mean, there are a few things I can think of already. Better graphics is one, and what I'm thinking of doing is, instead of starting with all 12 pieces on the board, I was thinking like having buttons, 12 buttons down here. So because each button can be a lot smaller than the piece themselves. So buttons down here with the symbol of each piece on it, and then you can click on the button to pick up the piece, and then the rest of it will function the same way, except when you overlap, instead of bouncing here, it'll bounce out of the game area. Or rather, as far as you can tell, it'll just disappear. And then to pick it up again, you need to grab the piece, or grab the button to pick it back up again. So that way we save space up here, because at the moment, all this space here is taken up by the need to have these areas for the pieces to dock, right? Whereas you can kind of have a bigger board area if you don't need that, basically. I'm thinking different game modes. Well, different puzzle targets, because this rectangle, the 6x10 rectangle, that's the basic pentomino background. You can make other shapes with it. Like you can make a longer rectangle and an even longer one, but those are actually more difficult. Or you can have partial puzzles. You can kind of have like if I can rotate this, imagine if that maybe you kind of use 3 pieces to make a smaller rectangle. Maybe that can be an easier puzzle, and then you can make kind of odd shapes as well. You can kind of, I don't know, make funny shapes with it, like I don't know. I don't even know what to, like a man with an umbrella, and he's got his arms sticking out for no reason. Actually, you can't really see the bar, can you? Let's just do that. I don't know, it's funny. And then you can draw funny symbols with it, maybe, and then you can have those as puzzles as well. So you can, you don't have to stick to the 6x10 So I'm thinking like maybe as a series of puzzles involving more and more pieces, and maybe a higher complexity as you go up, or a higher difficulty as you kind of keep going. So that might be more interesting, especially for new players. I mean, for someone like me, I've been fiddling around with this thing on and off for years now, so I know this puzzle in and out, right? So I know the backs and fronts of everything about this puzzle. So it's easy for me to kind of solve this thing. Well, it's not that easy, but I know what to expect. Whereas someone who's completely new to the Pentominoes thing, it might be better to start them off with something easier, right? Just to introduce them to some concepts. Things like the cross, you can't really rotate or flip it, or you can, but it's the same shape no matter what. Whereas some of these other shapes, they're different depending on whether you flip them or not. And so that's kind of interesting. Like the T, it doesn't really flip because it's symmetrical, but you can rotate it. Things like that. So you can use different puzzles to convey these different mathematical and geometry concepts to the players. That's what I'm thinking. So there's that. There's the buttons to pick up the shapes so that you can save room up here. Better graphics. Maybe some sound. Maybe a timer? A timer might be interesting. Somebody write that down for me? Like a timer. That might stress people out though. Maybe that's an option. So, anything you can think of that you might want to add to this to make it better, then so just to write that in the comments, in the video comments, and I'll be interested to see it. And I don't promise to use every single idea, but I just want to see what I might use. So things like so what did I say? Better graphics, buttons for pieces, and what did I say? Maybe sound and oh crap, I've forgotten it already, haven't I? See, that's why I need this written down, right? What did I say? Better graphics, buttons for pieces, maybe sound. Timer, maybe timer. Different puzzles with difficulty curve, right? Things like that. So anything you can think of, like I don't know, gravity gun, maybe I don't know, ponies, anything that you might think would be great. So just type that into the comments. That'd be great for me. And down here, like if you go to that page, you can kind of see the code. I've copy and pasted all the code. I don't know how many of you are familiar with programming in Flash. Basically, there's a graphical thing where you can draw the board and you can draw the pieces, right? And you draw these things, and you give each piece a name, which I have. And then there's also the coding stuff, and you can write these bits of ActionScript codes in each frame. I don't know if that makes any sense to any of you. If you haven't programmed in ActionScript before, that might not actually make sense to you. There's 350 lines of code or something here. So if you are an actual programmer, if you've done any sort of programming before, so how can I improve my code? I mean, I'm actually interested in learning more about programming. So even if you don't know about ActionScript so much, like if you just if you program in a different language, like I understand that there are certain things you can do to make code better, like make it easier to read, easier to manage, remove errors, make things more efficient, more elegant. Like if you've never programmed before, it might not make any sense to you, but there is good code and there's bad code, right? And there are ways to make code that is more reliable and more manageable. And then there's basically there's a tidy code and untidy code. And if your code is a mess, then it's gonna be like Minecraft. It's gonna be full of bugs. I shouldn't say that. That's kind of mean. But yeah, Minecraft is somewhat notorious for not having very good code. There are other programs as well. Tribes, I don't know if you've heard of the game Tribes. Tribes was notorious for having really messy code. And when you play a game, you find bugs and game crashes and things like that. That's because of bad code, basically. I mean, if you write the code well, it shouldn't crash, there shouldn't be bugs, things should just work. So that's the difference between good code and bad code. At least, the things you can see in crashing and bugs and things like that. So I mean, if you're a programmer, how can I improve my code? I mean, I do actually pay attention to this stuff and I try to write good code, but I've never studied programming, seriously. No, I'm mostly self-taught. I kind of just read books and then try to throw bits of programming together. So if you actually have more experience than me and you can read my code and you see things that I should improve, then go ahead and give me that advice too. How can I improve my code? And oops, I should move this. That's all the basic stuff for now. I mean, I didn't record me trying to figure this stuff out because that's probably interesting for you guys, or some of you guys at least. Watching me trying to figure out these programs. But I'm using Flash, and I haven't bought Flash, so I don't know how that would work really. I mean, I only make videos of games that I've bought and played. I mean, I haven't bought Flash, and then the Flash trial period is only like 30 days. I mean, I spent 7 days on this, right? So, and then after that, I have to pay for Flash to actually own it. But then it's like $20 a month. You don't even buy it. You subscribe to Flash, and you pay $20 a month to use Flash. I mean, if I was an actual software developer and I made money from my games, then maybe it would make sense for me to pay $20 a month for Flash. I don't. I just want to mess around with it, right? So I really don't know if it's worth me buying Flash. And then if I don't buy Flash, I don't know what it means about me making videos, about me showing you things that I've made in Flash that I haven't bought. You see what I'm saying? Does that make sense? So I don't really know if I should make videos of this stuff. And I really wish Flash would do what Unity does. Like Unity 3D, there's a free version, and you can make some basic stuff with it. And then if you pay, you can make better stuff. Like I wish Flash would do that. Then I'd be much happier to just kind of play around with the free version and make stuff. And then if I ever really become a developer that makes money, then I'd buy it. I would, really, if I made money from it. So anyway, I don't know how much. I probably won't make too many more videos of Flash, but since I've made this, I just thought I'd show you this. Okay, so from now on I'm going to talk about code. And this might be really kind of boring and obscure for you. I don't know how many of you would be even interested in this sort of stuff. But we're going to look at code. I'm going to show you what my code is, for better or worse. So this imports ActionScript. Actually, I don't even know enough about programming to explain ActionScript to you. It's what Flash uses. It's kind of like C. I think it's kind of like C++. Kind of. It's also kind of like JavaScript. So if you guys are familiar with that, it should be fairly easy to understand. Although a lot of the what do they call it? The methods and properties. And what's the other thing let me just try not to show you my inbox too much. Oh, that's my university thing anyway, it's not important. So this is help.adobe.com. So learning ActionScript 3. So they try to teach you this. Oh, there's the other programs too, like Flash releases the Flex software development kit, so you can make programs out of ActionScript for free. So that stuff is free. Flash costs money, but they have a thing where you can make ActionScript programs for free. But then you don't have the Flash environment, and it makes it kind of more difficult. Which is weird. Like, if you're really good at programming, you can make Flash programs for free, because you can figure it out. If you don't know anything about programming, you have to pay a lot of money. Does that make sense? Because what happens then is, if you're an expert and you know enough about this to do it for money, you can do it for free. But if you're just a beginner starting out, you have to fork out a lot of money to get started. I feel like they've got that back to front. Shouldn't they make it so that the experts who are making money from this stuff should be the ones who pay money? And then the beginners should be the ones who don't have to pay money? Wouldn't that make more sense? Anyway, I'm not going to spend too much time complaining about what their pricing thing. Let me just... Common program elements. Yeah, I won't complain about the pricing too much. Operators commands flow control. That's not really what I want to look at. What I really want to look at is, and for some reason this is really slow. Common example, working with objects. Go on, working with objects. Yeah, so there's properties, methods, and events is the other one. So this because Flash is a graphical program to start with. I mean, I'm sure you've all played Flash games before, or you've encountered some sort of Flash program on the internet. Like, it's interactive, right? You kind of click on buttons and things happen and graphics happen. So it's mainly graphical. So then, each one of these pieces I'm clicking on, they are actual objects in the program. That makes no sense, I'm pretty sure, if you haven't used this before. Well, let's just say then the script references these objects, and you can write, the script to manipulate the objects that you see. So, I mean, when you draw this, in the background, it's adding these things into the script, but you can't see them. But you can also create objects from the script. So these things are defined via script in the program, and then you can, use other script to control and manipulate the objects. So here, when I do this, basically I'm telling it, when I click on one of these things, move it around along with the mouse. And you can see it's actually lagging a bit there because my computer's lagging because I'm recording this thing. So this thing is just kind of following my mouse around, basically. Usually when you just play it and your computer's not doing something else, like recording a video, it would be pretty smooth and you won't see it lag like that. And then when I press a button, it rotates and things like that. So that's basically the script saying, when the keyboard does something, then tell that piece to rotate. That's basically what it's doing, right? So let me just kind of go through this. This import stuff is added by Flash itself. It's importing these libraries, which we need. This is mouse event, and that's keyboard event. Basically, this is the mouse and keyboard control. But I didn't do that. So we first start off with the variables. There's the grid size. There's 20. So this stuff is basically defining this. I don't have to. It's good programming practice to kind of make a variable for these basic things. So if I want to change the grid size, I can do that. But I'm just going to leave it as 20. Basically, that's 20 pixels by 20 pixels is the grid. And then the puzzle boundary is an array. Basically, that's like the top, the top left corner and the bottom right corner, X and Y. And this thing is 600 pixels by 400 pixels. That's why it's 600 and 400. Again, I can change that later on if I want to change for any reason, change the design of the program. So the rotate key and the flip key, this is Z and X. So that's just the input codes. So when the keyboard event happens, and it watches for these codes for Z and X. Piece parts 5. So there's 5 parts to each puzzle piece. You see this thing here. It's 5 squares, right? Each of these is 5 squares. That's what they call pentominoes. Pen is 5. So dominoes is 2 pieces or 2 squares, and this is like 5 squares. So that's just the puzzle. And I need the 5 because the rest of the data references the pieces. Like when I check for overlapping and things like that, you go through each of the pieces in each of the parts, each of the 5 parts of each of the 12 pieces, and it kind of looks for overlapping, if that makes sense. So here we also put the pieces into an array just to make it easier to manage. So instead of referencing each piece by name, when I put them into the array, I can just say pieces and then a number, and then it will pick up, or it will be referencing that piece. And so there's 12 pieces here. If I kind of drag this way, so there's 12 pieces there, and there's 12 more pieces. Each of this is basically 2 pieces or two movie clips in Flash, because you see how that overlaps the other pieces. But then when I pick up the other one, it overlaps the other pieces. It's just how I've managed the overlapping so that you don't slide pieces underneath other pieces. so that when you look at it, it looks like everything's always on top, or the thing you grab is always on top of the other things, which is how I've done it. There are other ways to deal with overlapping, but I found this to be the easiest to manage. So there's 12 pieces, but then there's 2 pieces, or there's like 2 movie clips for each piece, if that makes sense. There's an upper one and a lower one. Does that make sense? If it doesn't, then well, I don't know. I don't even know. Alright, so then here we have the docking areas for the 12 pieces in X and Y. Again, I put them in the array just so that we can kind of reference each piece by number, and then you can access all this data by number. So X and Y, so this is where they dock, and the docking means how when they move back to there when you overlap. So that's the docking position, or there and there, right? And in the comments I've written that I can move the docking to outside the puzzle area, and then have smaller button areas to pick up each piece. So that's what I was talking about earlier, right? That's what I mean when I say buttons for pieces. So instead of having the pieces on the page all the time, just move them away to give myself more room. So that's what that is. Variables for rotation and flip for each piece, because each piece you can rotate it in 4 times, and you can also flip them over and then rotate them 4 times again. So I just made variables for that as well, just to say whether it's been rotated and whether it's been flipped. It's not actually needed because the movie clips of the pieces themselves also has those variables, because you manipulate those variables to actually make it move. So we can actually read the data from that instead of having an extra set of data in this array. But I really found this easier to manage, to also have this in the overlapping detection code and other things. Like I found it easier to kind of have this extra data instead of reading it out of the pieces themselves. Maybe that's wrong. Maybe I don't actually need this. Anyway, that's what I've done, and it works for me. And then here we have some big long numbers. So for each each piece there are 5 squares, right? So basically this is the offset. So 0 0 1 0 1. So that's 5 squares. -1 0 0 1 1. So basically this is just the offset, X and Y offset for each piece. So basically if I pick that up, see how the middle square on the left there follows the mouse. So that's 0 0, X and Y. So the one above it is 0 -1, right? So it's the same X coordinate, but 1 square above, and then so it's 0 -1, 0 0, 0 1, 1 0, and 1 1, and that describes the 5 squares for that shape. Does that make sense? Anyway, so then there is there's 5 squares for each shape for all the other shapes, and so then this defines all of the pieces. So there's kind of 60 numbers here, and they're just offsets from the origin of each piece. That's kind of obscure, isn't it? Hopefully that makes sense to you guys. And then here, variables for which piece has been grabbed. So when you click on a piece, you're kind of picking it up. So -1 means nothing has been grabbed, but once you kind of click on one of these things, so the variable is changed from 0 to 11, so there's 12 numbers for 12 pieces, and then that matches the array. So the array is like 0 to 11, and 0 to 11, and then 0 to 11 there. So the grab variable matches the array number for each piece. So then that's how I can pick up each piece and manipulate all the variables quite easily. The overlap counter, we don't really use it, and we only use it in the check overlap function. Well, we use it in the check overlap function and in the put down functions, because when you put down a piece, then you check if they overlap. I'll explain more about that later on. And then the part coordinates output, basically here where there's a function to get the coordinates of each part of each piece, and that's also to check for overlap. That's another kind of variable that we don't use until later. But that's also kind of you see what it's used for later. Alright, so maybe I should show you the other stuff first. So the functions are here. Let me just go down to the bottom and just show you this. So these are the event listeners, right? So the entire stage, which is basically the entire program, the entire stage has an event listener for keyboard, for key down events. So when you press a key, it sends it to the rotate function. Maybe that's not a good name for a function, because that's also a method, I think. Yeah, okay. That might be a bad thing. But anyway, there's a rotate function. And you know, when you press a key, it calls the rotate function, which is basically rotation and flipping the pieces. And then each piece has a function, or each piece on when you click on it, or when you hold the mouse down on it, it calls the function for the pickup of each piece as well. So these are the pieces there, and the functions for the pickup of each piece. Maybe I should actually never mind. That's fine. That's fine. So there's 12 pieces, and they're called B, F, I, J, L, T, U, V, W, X, Y, and Z. So that's basically just, you know, what the shapes look like. So that looks like an X diagonally, you know, that looks like a T, and that looks like a Y a little bit, looks like a Z. So that's just how I call them. Alright, so when you click on each of these things, they call the functions, right? And there's also an event listener for the whole stage for mouse up. So when you release the button, you put down the piece you're holding. Doesn't really matter which piece you're holding. It doesn't really matter which, you know, in which part of the program you lift the mouse. No matter where you do it, you put the piece down, basically. Alright, so that's the event listeners. And those functions are really simple. They just set the grab variable. So, you know, when you click on the B shape, it grabs, it's set to 0, that's piece number 0. Pick up the F, you grab to set to 1, you pick up piece number 1. And so on and so forth for all 12 pieces. And you see what happens with the grab, you know, down in the frame 2. So in the frame 1, you just kind of, you know, define all the functions, basically. Actually, maybe we should go to that right now. Yeah, let's do that. Alright. So, once you grabbed anything, so if grab is greater than -1, because remember, -1 is when nothing's picked up. So if you picked up piece 0 or 1 or 2, you know, all the way up to 12, if you pick up any of the pieces, then the piece you grabbed, the alpha means transparency. It means, so 100 means it's fully visible. Because as I said earlier, there's actually 2 layers. There's an upper layer and a lower layer. The lower layer, you know, is underneath. So when you pick it up, the upper layer, that's the one with the black outlines. That one appears. And because that's on an upper layer, it's always above the other shapes. And then when you put it down, it disappears again. So basically, that's just the transparency thing. I turn the transparency on, and then I make the pieces follow the mouse, except when it's at the boundaries, or outside the boundaries, in which case it sticks to the boundaries. I actually should change some of these numbers. Actually, I do want to change some of these numbers because wait. Yeah, I want to change some of these numbers because I want to differentiate between the game boundaries and the puzzle boundaries. Because okay. First I'll describe what happens. So you see this, as I move the mouse there, it will drop it back into the... Actually, it's not even working, is it? Well, anyway, because I made it so that it drops the pieces if you move the mouse out of the game area. If I didn't do that, then the piece would kind of slide around at the edge but not follow your mouse any further. But because I've made it so you drop the piece, it will drop the piece there. I mean, you might think that kind of makes it redundant for me to keep the code that makes it not follow your mouse out, because you know it doesn't follow your mouse out anyway. It just drops the piece back in. Yeah, that's true. but it does avoid some glitches. Like if I have the code drop the piece when your mouse moves out, but I don't have the code for keeping the piece, inside the boundary area, it does glitch a little bit, I think. Anyway, I think that helps. So here, so you see how, so this here, if the mouse x coordinates is, inside the puzzle bounds, then the piece you've grabbed follows the mouse coordinates. So the x coordinate of the piece you grabbed is the same as the x coordinate of the mouse, and then the same for the y. And then the other one's basically just keeps the pieces inside the puzzle boundaries. And then the lower piece, which is the pieces p, follows the upper movie clip, which is the pieces. Hopefully that makes sense. So this basically makes both the upper and lower movie clips follow the mouse around. That basically is all that does. And then if the mouse moves outside of the puzzle bounds when the piece is picked up, then it's dropped. So if the mouse is outside the puzzle bounds, so this is gonna x. If it's less than 0, so it's outside this way. If it's more than, if it's less than 0, if it's out, above, or more than, 600 or more than 400 this way, then put down. The put down basically drops the piece. Maybe I should try the code without this. I'm really not sure. Like reading the code, it seems like I don't need this. But the last time I removed this, it really glitched out, and then the pieces didn't really drop in the correct place. I'm really not sure if I need this or not. I should double check that. Anyway, so that's all this does. So all this does in frame 2 is if you're holding on to one of the pieces to follow your mouse around, and if you move your mouse outside of the puzzle boundaries, it will drop the piece. That's basically all it does. Right. So back here, so the function here is put down. So the put down, remember that you can release the mouse to put a thing down, or you can move your mouse outside the puzzle boundaries and it will also put the thing down. So if you have actually grabbed the piece, and if you call the put down function, and a piece has been grabbed, then the piece you grab snaps to the grid. So here we're reducing the x coordinates of the piece to, or we're dividing it by 20 and we're removing the decimal places. So we're rounding it to the nearest 20, or actually then we multiply it again. So we round it to the nearest 20 and then put it at the center of the square for the x, and then we do the same thing for the y. So that snaps it to grid, right? Because we kind of, we're kind of snapping it by, rounding it to the nearest 20. And then we move both the upper and lower movie clips, also to that position. So it snaps the grid, and then it calls the check overlap function, this. Right, so let's go to the check overlap function. What the check overlap function does, or maybe I should go through the other stuff first. Actually, I should go through the other stuff first. So it checks for overlaps, and if the number of overlaps is more than the number of pieces per, or number of parts per piece, because what happens is when it checks for overlaps, the piece will always overlap with itself. Because that's just, the check overlap function, it checks for overlaps for every piece, for the piece you picked up with every piece, including the ones you picked up. So it would always overlap itself, and therefore 5 overlaps means your piece is only overlapping with itself, whereas 6 overlaps means that your piece is overlapping one of the parts of the other pieces. So then any more than 5 means you've overlapped, in which case it resets the rotation of that piece, it resets the flipping of that piece, and then it moves that back into the docking position. And it changes the rotation and scale back to nothing, back to the default. And then it moves both pieces back into the docking position if there's any overlap. So if you drop a piece and it overlaps any other piece, it moves it back into the docking position. That's basically what this does. And then it makes the upper movie clip of that piece transparent again, so it sets the alpha to 0. So when you drop it, it's no longer outlined, as you see. And then it unsets the variable for grabbed. So grabbed equals -1 means nothing is grabbed. And that's the end of the function there. So when you drop it, it snaps to the grid, checks for overlaps, and then it unsets the variable here. That's basically it. So rotate, that's a different one. So remember the rotate or the keyboard event function is always on. So at all times it's checking for you pressing any of the keys. And here, if a piece has been grabbed, so again, actually this is inconsistent, isn't it? That's greater than or equal to 0. Whereas here if it's greater than -1. Maybe we should change that as well, because they mean the same thing. So if any of the pieces have been grabbed, and if the rotate key is pressed, so if the key code is the same as the rotate key, which we set it earlier on at the beginning, then if the rotation of the piece that's been grabbed is less than 270, rotate it by 90 degrees clockwise. Otherwise, change to 0. Basically, if it's 0, it goes to 90. If it's 90, it goes to 180. If it's 180, it goes to 270. But if it's 270, then if it's still 270, it'll go to 0. So basically, that's it. That seems a little bit strange, but it works. And then it sets the rotation, or it sets both the upper and lower movie clips to the same rotation. Or if the flip key code is pressed, then it changes the value, because it's a Boolean value, or it's either true or false, right? So if it's false, it flips it to true. If it's true, it flips it to false. And then it sets the graphics, the scale x basically means it's the x scale. So if you change it to -1, it basically flips it around horizontally, or by the x-axis, right? And then it'll flip it around basically if you press the flip key code, and that's basically it for that function. So if a piece has been picked up, then you press rotate, it rotates 90 degrees. You press flip, it flips horizontally. So that's that function. And then the check overlap function. Remember that's called when you put the piece down. We've defined some local variables. So basically that's one part of one of the pieces, and then another part of another piece, and then we check them to see if they're the same. And if they are the same, we say there's an overlap, right? So we need to get 2 coordinates for comparison. And here we set the overlap to 0. We reset the overlap counter. So here for I equals 0, I less than a number of pieces, I plus plus. Basically, it's steps. And so it's I equals 1, and it runs everything in between the brackets, and then it goes I equals 2, and then I equals 3, and then runs everything in through the brackets until it gets to 11, because it's 0 to 11, so it's 12 pieces. So it goes through that 12 times because it's 12 pieces, and then J, it goes through that 5 times because it's 5 piece or 5 parts to each piece. Although here I've used the variables instead of the actual numbers. So 12 times, 1 for each piece, 5 times, once for each part of each piece. It gets the coordinates of that. So it gets the coordinate of each part of each piece, and it saves that to number 2, part coordinate on number 2. And then here K is also 5 times, because the piece you've picked up also has 5 parts, and it gets the part coordinates of the piece you grabbed, and also 1 to 5, and it puts that to part coordinates number 1. So then if the part of the piece you picked up is in the same location as the part of the piece, that we're checking against, then the number of overlaps increases by 1. Does that make any sense at all? Basically, it goes through all of the possibilities, right? It checks every part of every piece on the board against every part of the piece you've picked up, and it basically just counts how many times one part overlaps another. And as I said before, the piece you picked up will overlap with itself, so that's 5 there. And if it's any more than 5, then you know that it's overlapping something, and then you need to move it back into the docking position. That's basically what we're doing here. So there's some previous code that I didn't use before. So this is yeah, that's not. Previously, pieces were disallowed from overlapping docking areas. Oh, that's right. So previously, like when I first wrote the program, I just made one like a single square for each piece. When I'm trying to figure out the code for rotating and flipping and just moving them around. So this was before I actually had the proper pieces in. Now that I have them in, I would need more complex code for checking for overlapping in the docking areas. And we need this because, like, you see what happens here, right? So imagine I move this, I put another piece here just for the hell of it, and then I overlap this onto another one. It'll move back to the docking area, and it'll create an overlap there. So conceivably, I can end up overlapping quite a few of these shapes. If I just do that, and boom, that thing's gone. It's just, actually I can do this better. If I just kind of rotate this around. So if I for some odd reason choose to do that, and then overlap this, it's gone. It's gone. Well, it's not really gone. I mean, it's underneath here. But you see what I'm saying, right? Because this thing gets moved back to the docking position, but there's already other pieces there. Then it's buried underneath the other pieces. So what I wanted was basically to make it so that if any of the pieces overlaps a docking area, that also counts as an overlap, and therefore that also moves the piece back to its docking area. But I'm thinking I would rather just move all of the docking areas off the stage, as it were, or outside the boundaries that you can see, and then have the buttons. That would make it even better, I think. So that's probably not necessary anymore, and I've commented this stuff out, so it doesn't actually run anymore. Right, so this is the function part coordinates. So this is getting the coordinates of whatever part you choose, and you input the piece number and the part number, and then it will output the coordinates of that part of that piece, basically. So at the beginning we're resetting the variable there. Maybe I should, never mind. So at first we reset the variable for the output. Then that's really complicated. That's really complicated. So basically there's 8 states for each part of each piece. So each piece can be rotated 4 times, and it can be flipped once. And there's 4 rotations for the flipped state as well. So there's a total of 8 possible positions. Actually, let me just show you. That kind of makes no sense, doesn't it? So there's that, and that, plus that, and that. So there's 8 possible things, or 8 possible shapes that the piece can be, depending on whether it's rotated or flipped. And so here you see this is if the piece, or if the rotation of the piece is 0 and it's not flipped, then you get the origin of the x coordinate of that piece plus the offset based on based on these numbers back here. Remember how we had the offsets for each part of each piece? So we multiply this by the grid size, which is 20, and then we add that to the x and the y coordinates of the piece, and that gives us the coordinates of that part of that piece. Does that make sense? Because the offset times the size of the grid added to the origin of that piece equals the coordinates of that part of that piece. Hopefully that makes sense. So there's no rotation and not flipped, and then there's one rotation and not flipped, two rotations and not flipped, three rotations not flipped, and then no rotation and flipped, one rotation and flipped, and so on and so forth. And each of that results in a different transformation of the piece, and therefore it requires a slightly different calculation for what the coordinates of the part of the piece is, and so on and so forth. But let's just kind of believe that this works, and it does. I've actually spent a little bit of time trying to figure this out. But you can just trust that this works, or you can read it yourself, basically. And then you take all those numbers and you put them into the part coordinates output and part coordinates output, and that's basically it for that function. That kind of really complex, calculation. It's not that complex, really. It's not really that complex. It just looks. I think it looks more complex than it really is. But it outputs, to that, and then we can compare the coordinates of two pieces, basically. And then we're back to the listeners, and then so that's frame 1. So frame 1, we define all the variables, and then we write all the functions there. Frame 2, whenever you grab a piece, it runs, or it basically just move the piece with your mouse, and then it detects when you drop it. And then frame 3 or frame 3 basically just says go back to frame 2. I don't know. I don't think this is the best way to do this. I feel like there's a better way to do this. But basically, from frame 2, you do all the things you need to do, and then frame 3 just says go back to frame 2 and do it again. So that I think it's not the best way to do this, but I don't actually know how to do it better. So yeah, okay, and then that's the whole program. I don't know if that was interesting for you guys or not. I don't know how many of you guys are programmers. That might be just complete, I don't know, we might not even be listening to this anymore. Maybe just kind of playing the game and not caring about what I say anymore. Okay, so that's 7 days of not very serious programming. So once again, the link to this page is in the video description or there on the screen right now. I'm interested to hear what you think I should add, and any features I should put in that might make this better. I'm interested to hear about it. Again, it might take me forever to actually finish this thing, because I'm not that interested in making games. I kind of am, but it's kind of also a lot of work. And then also, if you are a programmer, how can I, or what things should I pay attention to make my code better? I probably won't rewrite what I've done already. But actually, I've already done it. Like you see, this is like version 0.16. This is the 16th, iteration of this. This is the first one that you can actually play and move all the pieces around, right? Yeah, but I actually did a major rewrite a few versions ago, just to get things better, right? And I mean, it's good. It's a good learning experience. So any tips or hints, if you're some sort of coding expert, then I'd be happy to improve myself. Yeah, I would. And I guess that's basically it. Again, like no promises that I would actually finish this, or that I would adopt any of your suggestions. But I am somewhat interested in programming, and so there you go. You can see what I've done. You can add comments here, but I don't actually know if I get any notifications. So you might just kind of leave a comment, and then I just don't even know about it. And yeah, that's it. I guess I can't think of anything else for now. You feel free to kind of just show other people this stuff. Don't sell it, because it's mine, copyright and all that. But really, you can probably just do whatever you like with it. I don't really care that much. Alright, I'll stop here.